All right, so today I'm going to start talking about polyatomic ions. So we've talked about ions, we talked about what turns atoms into ions, we've talked about how to name or predict what sorts of compounds are going to form and name those compounds. Now I'm going to add an extra complicated thing into the mix, just one additional little detail here that can make things a little trickier. And so far, all we've seen are what are called monatomic ions, which is one of the two categories we can have. So a monatomic ion is just an ion formed from a single atom. So like sodium or sulfide or phosphide or even even the variable, they're all just a single atom that gained or lost electrons to get a charge. But you can have actually a group of atoms that gain or lose electrons. So these are called polyatomic ions, meaning many atoms. So simply, we have a group of atoms held together by covalent bonds. So in actuality, these polyatomic ions are effectively molecules that have gained or lost electrons to become polyatomic ions, to become ions. So here you might see something like sulfate, which here's an example. So SO4 2 minus. So that is an example of a polyatomic ion. So you have 4 oxygens and a sulfur all bonded together with a -2 charge. There's a couple important things about the polyatomic ions you should know. That when you see the polyatomic ion, and this is really critical, that the charge is evenly distributed and is not attributed to any one atom in the ion. There's also this kind of common misconception that it's actually going to be like -8 or something because there's 4 oxygens. This number doesn't really interact with this number up here. This is just telling me how many atoms are here. So it's a group of 1 sulfur and 4 oxygens, and all together, all included, it has 2 extra electrons. It has a -2 charge. And that charge is not really focused on it doesn't belong to any one atom. It's just evenly spread throughout the molecule and throughout the ion. In fact, I mean, in reality what's happening is the electrons are just moving around really quickly, so it's hard to sort of track exactly where they are, where they belong to. Actually, I need to change the page number here. The list is on page 102. Sorry about that. It's page 102, new edition of the book. It's on page 102. So you do have to memorize them. There is this looks like a 103 up here now. So let me erase all this. Page 102. I keep writing the wrong thing. 102. You have to memorize all of them. You've got to get them down. You cannot name them if you don't know them, right? And you can't go looking them up every time. So here they are. Here is the list from the old book. The new list is the same. It just looks a little fancier. There's a lot here to memorize, so you need to get going. This is why I put this on the list of things to memorize at the beginning. Hopefully you've already been working on this. Hopefully you've already been doing this. Note cards are a good way, flashcards are a good way to start memorizing these. Now, here you go. So what you need to know is you need to be able to go from the formula to the name. So if you see nitrate, you need to know that that's NO3 -1. The charge is part of the formula, right? The charge matters, so that's part of it. NO2 negative is nitrite, and so on and so forth. Now, there's a lot of these, but I think there's a way I can help you kind of organize your thinking on these that's going to help make your job a little easier. And that's fundamentally this. You'll notice that a majority of the ions they're negatively charged, right? There's only 2 positively charged ions on here at all. And I'm not even finding the other one. There it is. So the two positively charged ones are NH4 plus and H3O plus, right? And this one is called ammonium and hydronium. That looks like a 4. Right? So there's an ending that works to say this is a positive ion, a positive polyatomic ion. So our two positive polyatomic ions are two polyatomic cations end in onium, ammonium and hydronium. The rest are all negative. And both these are positive 1. The rest are all negative. And they can range anywhere from -1 to -3. So if we look back, -1 to -3. So they're kind of all over the map. Now, one thing is that there's a lot of 8s and ites. There's a lot of 8s and ites. There's a couple ides, but I'll get to that in a moment. If you can memorize these 5, this will help you a lot. If you can memorize sulfate, carbonate, phosphate, nitrate, and chlorate, you will help yourself a lot. So this is sulfate, carbonate, phosphate, nitrate, chlorate, right? So it's named after, you know, the non-metal that's with the oxygen. They all have some number of oxygens and a negative charge. Now, what the number of oxygens are and what the charge is don't really follow any really nice, easy to memorize pattern. But if you can get these 5 in your head, just these 5, you will then be able to memorize a large number of all of the others. Because if you'll notice, here is sulfate, right? And here is sulfite. So notice the difference between the two. Here's phosphate, here's phosphite. So maybe you're seeing a pattern now, which is, if you know which one is 8, the ite has the same charge, but 1 less oxygen. So if you know sulfate, now you know that sulfite is SO3 2-. If you can remember sulfate is SO4 2-, just drop an oxygen, now you have sulfite. Phosphite, it would then therefore be PO3 3-. Nitrite would be NO2-. Chlorite, the ClO2-. Now, the chlorine series actually goes 1 more in either direction. ClO- and ClO4-. They all have the same charge, but the number of oxygens is changing. So there's a word meaning below. So 1 less oxygen than chlorite is hypochlorite, right? 1 less oxygen, so below chlorite. Now, you might be inclined to think that up here this is then going to be hyperchlorate. You're mostly right. For some reason they dropped the HY, so it's just perchlorate. But it's the same basic idea, right? So hypochlorite, perchlorate, there it is. Okay, so that knocks a bunch of them out of the way. So if you can memorize nitrate, sulfate, phosphate, carbonate, and chlorate, then you also get perchlorate, chlorate, perchlorate, chlorite, hypochlorite, phosphite, sulfite, and nitrite all out of the way. Then I'm going to show you how to get a couple more of these. So based on this, a hypothetical carbonite, which you don't have to memorize, is going to be what? CO2 2 minus. And as far as I know, you can't freeze anyone in it. So now let me show you something else here. Okay, so let's take the polyatomic ion sulfate. Okay. So something kind of interesting happens. I can take and put H plus ions on the front, right? So I can combine H plus ions, and if I put one H plus ion on the front, I get HSO4. How is this going to affect the overall charge? If this is -2 and this is +1, my overall charge will, of course, be negative, right? So every time I stick an H plus on the front, the charge goes up by 1. So this becomes hydrogen sulfate, right? So we just are indicating how many hydrogens are out in front. So hydrogen sulfate, right? I can do this with any polyatomic ion with a little bit of an exception. I could take carbonate, right, and I could put this becomes HCO3 minus and becomes hydrogen carbonate. Now, you'll notice we don't have on your list a dihydrogen sulfate. Think about for a moment why not. The formula for a hypothetical dihydrogen sulfate would be H2SO4. What would the charge be? It would be neutral. So therefore, why is it not on your list? Because it's not a polyatomic ion. It's not an ion at all. If it becomes neutral, it's out of the ion category. So what actually happens if you put enough hydrogens, H pluses in front of a negative ion to make it neutral, you now actually have an acid. We'll talk about acids later on in chapter 10, but we'll come back to that. So that's why you don't have to worry about having like hydrogen chlorate, because that's actually an acid. It's not a polyatomic ion. So the only polyatomic ion I can really put two hydrogens in front of is, of course, phosphate, because it has a -3 charge, right? So I've got phosphate. So this would be hydrogen phosphate and dihydrogen phosphate, right? I can even do the same thing with phosphite, hydrogen phosphite, dihydrogen phosphite. And all of the ites as well. So I can plunk hydrogens on things. So this actually knocks out hydrogen sulfate, hydrogen sulfite. You don't have to memorize these, right? If you just understand how to build them off of sulfate, and therefore sulfite and all that, then you don't have to memorize it. Hydrogen phosphate, dihydrogen phosphate. I don't think hydrogen phosphite and dihydrogen phosphate are there, but they do exist. Hydrogen carbonate. Now you're left with just a few others, or two positives, and then all you have to know is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 plus those original 5 I told you to remember. So about 16 you have to memorize. The rest you can figure out. So that's still a chunk, but hopefully this makes it a little easier to deal with. Okay, I'm going to stop here, and then in my next video I'll talk about how to name compounds with these in them.